This is lesson 11.3 on the Pythagorean theorem. So we will be using this theorem that I'm about to teach you to find a leg length of a triangle or a hypotenuse of a triangle. So a couple of definitions first. When I say triangle, and we're talking about the Pythagorean theorem, it has to be a right triangle. And you will see that in the definition on page 588. In the key concept box, it says, for any right triangle, the sums of the squares of the lengths of the legs. So the legs of a right triangle are the ones that here's a little hint I always give my students. The legs are, I'm going to clean this up so I can show you something, are the sides that the right angle box points to. So you can envision two little arrows here. They're pointing to the legs of the right triangle. And the line across from the right angle sign, so this one out here, is called the hypotenuse. And it is usually C. In fact, will be C in the Pythagorean theorem. So what is the Pythagorean theorem? It is a squared. That's why the key concept said the sum of the squares of the lengths of the legs. So when I square the lengths of the legs, I have a squared plus b squared. And following along with the definition in the key concept box, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So if A is 15 and B is 20, you should know these two squares because you can have your little cheat sheet out where I told you to do all the squares to 25. So you would know that you just plug in what you know, okay? So 15 squared is 225 plus 20 squared, which is 400, will give you C squared, okay? 225 plus 400 is 625. You can look again on your cheat sheet to see what the square root of 625 is, and you should see that it is 25. And that's how we use the Pythagorean theorem to solve for lengths of the sides of a right triangle. Unfortunately, this publisher gave very simple examples and then gave very difficult problems to solve in the book. So I am guessing there will be a part 2 to this, and I'll try to do some of the evens around the odds that I assigned so that you can understand what to do. I take that back. Example 2 at the top of 589 does require you to approximate. So, and that's what I think almost every single one that it's in the homework has approximating to the nearest tenth. So very similar to lesson 11.2 in that. All right, so example 2, I'll walk through with you. It says, for the right triangle shown, find the length of the hypotenuse. So very similar to the one we just did. Remember that you will have to plug in the values into the Pythagorean theorem. So I'm going to just sketch it up here again. A squared plus b squared equals c squared, and I'm going to plug in what I know. It tells me that the two leg lengths are 8. So I now know that 64 plus 64 will give me c squared. And 64 plus 64 is 128. If you look over at your perfect square cheat sheet, you will not find 128. So now you have to approximate because the directions say find the length to the nearest tenth. So we can't just round to the nearest whole number, but we have to do that to start getting to our answer. So the nearest square, perfect square under 128 is 121. That's 11. And then this will be 12. And so I know that my tenths place will fall in between 11 and 12. It's going to be 11 point something, okay? I'm going to start with 11.2 just as a guess, okay? And work out that multiplication. And I get 125, so I didn't go high enough. I'm going to try 11.3. Maybe I'll jump a little bit over it, and then I will know which one I can use. Add all this up. 127.69. Okay, this one's only 31 hundredths away. And so I'm going to approximate that C will equal, I'm sorry, not equal, because we're approximating, will be close to 11.3 millimeters. And that's how you do example 2. All right. Let's look at example 3. In example 3, it talks about a tent and ropes. And it says that the ropes that are used to hold the tent down are 5 feet long. Okay? And each rope attaches to the tent 3 feet above the ground. And you can see these measurements in the diagram. How far from the base of the tent should each rope be staked down? The base of the tent is here. So basically they're asking you, what is the length of B? Okay? Because you're staking the tent here. All right, so this time we are finding a leg length, not the hypotenuse. You still plug in what you know. We know A, it is the leg length of 3. So 3 squared would be 9. We do not know B, so I'm just going to put B here because that's what we're solving for. And 5 squared will be 25. Then I subtract 9 from both sides and get 16. I am going quickly. This is a skill you should already know. And this one ended up being easy. Too bad they already answered it for you because I don't think you're going to find many easy ones in the work. Okay, that's how you solve for a leg length. If this is making sense, try 1, 2, and 3 and then come back and onto the video. I'll work them out for you. I am going to tell you that number 1 in guided practice does not need approximation, but you will have to round 2 and 3 to the nearest tenth. All right, number 1, A and B are 12 and 9, and that will equal the hypotenuse length squared. So we have 144 plus 81 equals C squared. So I just need to add 81 to this. And I will get 225, which we've already covered in this lesson. So you should remember that that is 15. That's how you do number 1. Number 2, still solving for C. So we're going to have we're going to have 1.2 squared plus 0.5 squared is going to equal C squared. Now, you can still use your perfect squares for this, but keep in mind that we have decimal points. So I know that 12 squared is 144, and because I would be doing 12 times 12, or 1.2 times 1.2, I know that I need to put my decimal point right there. Same with 0.5. It's going to end up being 0.25 as an answer, okay? Then I'm going to add 25 hundredths to 1 and 44 hundredths to get 169, okay? And again, you can look over at your perfect square to see that 13 squared is 169. So I just need to apply my decimals again, all right? And you will notice it's the same as this. If I do 1.2 times 1.2, that gives me 1.44. So it follows that 1.3 times 1.3 would give me 1.69, okay? So there you go. I was wrong earlier. I said you had to approximate, but it's because I could see the answer was a decimal point, and so I assumed. But no, it actually did not require approximation. So another easy one for you. All right, and number 3, we have A and B given to us. 11 squared is 121. 9 squared is 81, and together those will equal C squared. So 81 plus 21 gives us 202, and that is not a perfect square. So here we go. What is the perfect square less than 202? I don't have a cheat sheet out here, so I'm going to guess that it is 169. No, I think I can get closer with 196, which I believe is the square root of, that square root is 14. Okay, so here we go. I'm really close to this 196 with 202, so I'm going to guess 14.2 for my approximation. Because last time we had one that was close, but it didn't end up being 0.1. So let's just see how the math comes out. 4, 8, 2, 8, 6, 5, 2 zeros, 2, 4, 1. 4, 6, this becomes 9, 11, 201. So again, I've gotten within 36 hundredths of 202. So I'm going to say that C is approximately 14.2. All right, guided practice 4. I'm not going to work out. Actually, I think I will, and then I will start a second video for the homework problems. Okay, number 4 in guided practice says to look at example 3 at the tent example, and it's changing the rope length to 6 feet and then asking what B would be. And it does say round to the nearest tenth, so we know we're going to have to approximate. So remember, plug in what you know. 3 is A, so I have A squared, which is 9, plus B squared equals C squared, which is 36. All right, and I'm going to here subtract the constant from both sides. That gives me B squared equals 27, okay? Not a perfect square. The perfect square lower than 27 is 25, so it's going to be a 5 or a 6, okay? Closer to 27 is 25. So again, I'm going to guess, I'm going to start my approximation at 5.2 because that's been good for me. All right, so I get this, and then I get this. And that brings me only 4 hundredths above 27. And so I would say that B would be approximately, whoops, I keep on putting an equal sign when we're just rounding. 5.2 would be the answer to that one.